Welcome to MFM2PI, 5th unit trigonometry. This is lesson number 7, solving right angle triangles. So the objective today, says it right there in the title, our goal is to solve right angle triangles. So what does that mean? When we're asked to solve a right angle triangle, it means to determine all of its missing values. Determine all its missing values. So when we're given a right angle triangle like this, typically there are going to be 3 pieces of information that we are given, and there'll be another 3 that we need to find or determine. So that's a total of 6 pieces of information, and as I said, you're often given 3. So the way to get a sense of how best to approach finding these missing values, the way that I like anyway, is to sort of start each question, and we're going to start over here. We're going to start each question by writing down all the things that we're given in sort of a little chart form. So I'm going to write out angle A equals, angle B equals, angle C equals, side little a equals, side little b equals, and side little c equals. And I'll do this every time that I'm solving a right angle triangle. Next thing I'm going to do is start to fill in pieces of information that I've been given. So I notice that angle C is equal to 90 degrees, and angle B is equal to 56 degrees. So there's a couple of angles that I've been given. I also notice that side little a is going to be 7. And that sums up what I've been given. Now that means that I've got 1, 2, 3 pieces of information remaining to get. How I do it is really it's a bit of a personal preference, to be honest. We're going to use the trig tools that we've been given, the sum of interior angles, the primary trig ratios, and the Pythagorean theorem. But there are often lots of different ways to go about getting your answers. So if you happen to solve a triangle a particular way that's different than mine, as long as our answers line up, then we'll be fine. So let's start with the most straightforward piece of information, and that's going to be angle A. So my number 1 is going to be to find angle A. And angle A, because I've been given 2 other angles, the most straightforward way to get it is to use the sum of interior angles, which is to take 180 degrees and subtract the other 2 known angles from it to give us an answer. So when I work that out on my calculator, that's going to give me 34 degrees for angle A. And then I write that right up here in my table. I like to keep all of my answers sort of in the same area so that I can keep track of where I've been and what I've been doing. So that's the first one. Now we've got 2 sides to find. We've got side little b and side little c. It doesn't really matter which one I get first, but I guess I'll start with side little b to keep it alphabetical. So here's my right angle triangle. If I've been given an angle and a side, and I'm asked to find another side, I'm going to use my primary trig ratios, which means I'm going to start by taking a reference angle, and from there labeling all 3 sides of my triangle: hypotenuse, opposite, and adjacent. So if I'm going to go after side little b, that's going to be my opposite. So I'm going to just set up number 2 over here, and number 2 is going to be find little b. And I'm going to start by writing out a SOHCAHTOA so that I can figure out which trig ratio I should use. So there's my SOHCAHTOA. As I said, I'm after the opposite this time, so that's O and O, so this is not going to be a cosine question. If I look back at that triangle, the side that I've been given is the adjacent, so that's it right there. So this is also not going to be a sine ratio question. Instead, it's going to be tangent. So I'm going to start by writing that out. The tan of angle B, which I chose as my reference, is equal to the opposite over the adjacent. And now we start subbing in pieces of information that we know. So we know the tan of 56 degrees is equal to the opposite side, which I don't know, that's little b, over my adjacent side, which is 7. And now, just like I did in other lessons, I'm going to set this over 1 to solve for little b. We're going to cross multiply here. Let me get my highlighter. So I'm going to do a cross multiplication here, and let's get b equal to the tan of 56 degrees times 7. And then I'm going to type that into my calculator. So the tan of 56 degrees, I'm going to multiply that by 7, and I'm going to get 10.377, so 10.4 will be my answer. And again, I'm going to put this right into the table, 10.4. So that's 2 of our 3 pieces of information. The next one I'm going to go after here is the last one, which is going to be side little c. and I'm going to sort of use the Pythagorean Theorem for this. I could also use the primary trig ratios again, but I'm just going to try to sneak this one in with a little bit more variety. So number 3 is going to be find little c, and I'm going to set up for the Pythagorean Theorem. So in this case, I've been given the two sides, but not my hypotenuse. So my hypotenuse, interestingly enough, is going to be c squared, and that will equal a squared plus b squared. C squared will be equal to, and I'm going to substitute in 7, which I know, squared plus 10.4, which will also be squared. I'm going to try to squeeze all this in here. So if I've got 7 squared plus 10.4 squared, that's going to equal 157.16. And in order to get c, I'm going to square root those guys, and that's going to give me c is equal to 12.53, so 12.5. And I will put that in the table, 12.5. And now as I look, I can see that I have got all 6 pieces of information that I was missing. So I have completed a solution. I have solved this right angle triangle. So hopefully this process makes sense to you. I think really the key learning here is that you're going to put that little table together at the beginning to keep track of what you're doing. And after that, you kind of just rock and roll with it. So let's jump to this one over here. Let's jump to this right angle triangle here. I would suggest that you hit pause at this point in the video and you give this a try. And then come on back when you think you've got it. You can check your answers against mine. And I'm going to work it out when we get back. Okay, let's have a look at this. I'm going to start with that little table as I said. So I've got angle A equals angle B equals angle C equals side little a, side little b, and side little c. And let's start to fill in the stuff that we've got. So we've been given side little b is equal to 3, and side little a is equal to 3, and angle C is equal to 90 degrees. So the 3 pieces of information I'm missing are angle A, angle B, and side little c. So let's just go about putting this thing together. I don't have an angle for a primary trig ratio yet, so maybe we'll start with going to get side little c, which we can use the Pythagorean theorem to do that. So let's sneak that in up over here. Number 1, let's go get little c. So find little c. So little c will be equal to, and again, this is my hypotenuse this time. So c squared will be equal to my a squared plus my b squared. C squared will be equal to 3 squared plus 3 squared. C squared will equal 9, sorry, that's 18, 2 9s, there they are, and we are going to square root these guys to get to C. So C will be equal to the square root of 18, which will give us 4.24, so 4.2, and I'm going to put that into my table. There we go. From this point, I need to pick a reference angle. I've got all 3 sides, which is great. I'm going to pick a reference angle. Let's pick B again, just because it's there. And from there, we're going to label our sides. So there's our opposite, there's our adjacent, and there's our hypotenuse. And this time, we're actually going after the angle. So we are going to be using angle B. So that's our number 2. We're going to say find angle B. And finding angle B means that we need to pick a trig ratio. So let's start that out with SOHCAHTOA. Let's see what we've been given. So from here, we've been given both the opposite and the adjacent. So that means opposite and adjacent. So sorry ka, sorry so. We are going to be using tangent again. So let's write out the bare bones tangent. So the tangent of angle B is equal to the opposite, which is 3, over the adjacent, which is 3. We're after angle B, so if you recall from finding angles, the way to do that is to do the inverse tan of 3 over 3. And I'm going to type that into my calculator. So I'm going to set up the inverse tan of 3 divided by 3. I'm going to close my bracket, and that's going to give me 45. And I'm going to put that into my table. So there we have 45 degrees. The last thing we want to do is go get that final angle. And if you've already got 2 angles and you're after the third, I always recommend using the sum of interior angles, which says that angle A will equal 180 degrees minus the 90 degrees minus the 45 degrees we just found. Angle A then will equal also 45 degrees. And I'm going to put that in the table. So there are the first 2 examples from this lesson. Now, it's entirely possible that this is enough for you and you are ready to go on to the self-check, or the self-assessment rather. That's totally fine with me. There is going to be a second video to follow this one where I work the final 2 examples, and if you need it, please take the time to work it out, or even work out those 2 examples in advance, and then just maybe fast forward through the video just to double check the answers. So that's all for lesson number 7, and do the self-check, and then you're on to lesson number 8, which is some real-world problems. So good luck.